All right, welcome back from spring break. I hope you had a wonderful break. Now that we're coming back, we're going to be talking about we're going to continue our conversation about endothermic versus exothermic reactions and actually give a cue into why each of these reactions show that endothermic or exothermic property. All right, so if you can think back to before spring break, over a week and a half ago, we were talking about those endothermic and exothermic reactions, right? Those endothermic reactions absorb heat from the surroundings, so when you touch those reactions, they feel cold. With an exothermic reaction, remember, heat is exiting the reaction to the surroundings, so when you feel that reaction, you're the surroundings, remember. When the surroundings feel the reaction, it actually feels hot because it's releasing that energy, it's releasing that heat. So what does this have to do with our new concept of activation energy? Well, this is kind of the explanation for why some reactions give off heat and some actually absorb that heat. So, when we talk about activation energy, does anyone know what activation means? If you think about the word activate, you might have heard it, I've heard it in some action movies. Something's going bad and then all of a sudden the heroes go activate plan alpha or whatever that is. So activate means to start. So activation, meaning to start, and energy. So activation energy is actually the minimum amount of energy required to start a reaction. Okay, not all reactions can just start at room temperature. So some might need a little bit of an extra push before they get going. So what you're going to do now is you're going to look at these two graphs right here, figure 1, figure 2, and look at least two similarities between the two graphs. From what I'm seeing, they both have energy of reactants on one side, energy of products on the other. I see a hump on both of them. I see seconds on the x-axis, energy on the y-axis. So pick two of those similarities and write them here. All right, so now we're going to go into the table in number 3. So in order to complete this table, we're going to have to look at each of the graphs that correspond. So this column is responding to figure 1 right here. So record the energy of the reactants. I'm going to look on my graph for where it's labeled energy of reactants. I see it right here. And we are right at 2. And let's look at our label here on the y-axis, 2 joules. So that's what I'm going to record. 2 joules, and joules being a measurement for energy. All right, and then energy of the products, I'm going to look at it the same way. I see this is labeled energy of the products. I'm going to follow that over. I see it right around 4. A little over, a little less. All right, now record the highest amount of energy needed to activate the reaction. So that is going to be the top of the bump right here. This is your highest amount of energy. And I see that line goes right over for us really nice, and that would be 8 joules. Okay, now we're going to calculate the amount of activation energy. So the activation energy is this bump here, and as you can see, it's actually labeled here. So it's going to be the top of the graph minus the bottom of the graph. So 8 minus 2 in this case, because 8 was the highest bump and 2 is the energy of the reactant. So from the highest bump to the start of the reaction equals 6 joules. So now we're going to calculate the amount of energy that is overall being absorbed. So that is only products minus reactants. We don't care how high it went in this case. We only care about the end product minus the beginning. So at the end we have 4 joules. At the beginning we had 2. So our overall difference is going to be 2 joules. So I'm going to let you do figure 2 on your own. and then we're going to talk about a summary. So we're going to write a summary about energy, reactants, products for each type of reaction below. So when it says about energy, reactants, and products, I want to make sure all three of those words are used in my summary. So that could look something like this. Energy is absorbed because, so I already checked off one of those words. The energy of the products is higher than the energy of the reactants. So checked off that word and products, okay? So I'm talking about energy is absorbed because the energy of the products is higher than that of the reaction. So if you have more energy at the end, it had to come from somewhere, so it got absorbed into the reaction. So now it is your job to finish up figure 2, do your calculations, and write a summary for exothermic. And the answers are on BB, already posted for you on BB9. Make sure to do this first and then go and check your answers. Otherwise, you will be wasting your time just by copying. Okay, so now you have a CER to write about endothermic and exothermic reactions. So we're going to talk about this. It looks really complicated, it looks like there's a lot going on, but we're pretty much just going to be doing what we did on the page 90 and transferring it over into a CER format. Okay. So we have our figure 1 and figure 2 that are exactly the same as they are on page 90. So let's look at them. We already determined that figure 1 is endothermic. Right? If it absorbs energy, it's endothermic. Think back to a week and a half ago when we were talking about that. That makes sense. So on our figure 2, we see we have about 4 joules in the beginning and only about 1 joule at the end. So energy has to be released because where did it go? It has to go out to the surroundings. So it would be released as heat, and you could feel that. So it's exothermic. It's releasing heat. Cool. Now here's something we talked about a little bit, but let's refresh. So now you're given 2 equations. So what you're going to be doing is matching up these equations to the figure that is representative of that reaction. How do you do that? Well, we're going to go back to our notes on page 88. Think about endothermic and exothermic. And remember, I'm sorry, not 88, page 87. And remember that for an endothermic reaction, we are breaking bonds because it needs a lot of energy in order to break those bonds, so it needs to absorb energy. And with an exothermic reaction, we are making bonds because when those bonds snap in place, they release energy. So in equation 1, we have aluminum and chlorine, and then at the end we get aluminum chloride. So are we making bonds or breaking bonds here? I see that bonds are made. And if bonds are made, it's giving off energy, so it's exothermic. It's that simple to tell from a formula. So if it's exothermic, the heat is going to be on this side, plus energy on this side, because energy is given off in the end. All right, so now we're going to talk about the table. Up at the top is just some things you already know. It's just giving you a layout, what you know, what do you need to know, what you kind of, we were talking about this, and then what we need to find out. How will we find that out? All right, so how do we fill this out? All right. So, we're going to start with our reactants because those are important. What are our reactants? Aluminum and chloride, Al and Cl2. All right, and our products. Over here we got AlCl3. Remember, those subscripts are very important. You can't leave off the subscripts, otherwise you're changing what it's being made. All right, and here we're making bonds or breaking bonds. We said we make bonds. That's not too bad. So, what do we need to know here? Is the reaction endothermic or exothermic? All right, so how do we figure that out? In our notes said making bonds is an exothermic reaction. That's it. Exo. You can't just put down page 87. No, explain to me what the notes said. All right, so you're going to be responsible for filling this out for equation 2. You can follow the exact same format. So now we're going to flip to the back. And we're actually going to write our CER. Okay, so for your claim and your evidence, we have some fill-in-the-blank style. All right, so for figure 1 represents the change in energy for equation. Which one did we say? We said equation 2, right? Because this was endothermic. So if equation 2 goes with figure 1, then equation number 1 has to go with figure 2. No, I'm sorry, we figured out equation 1 goes with figure 2, which is exothermic. So then you have to have equation 2 go with figure 1. So you should find that that is an endothermic reaction. Okay, so the energy of the reactants, which you should have already filled out on page 90. So the energy of the reactants is 2 joules. The energy of the products then would be 4 joules. And the total amount of energy are we absorbing or releasing? We are absorbing is 2 joules. Sorry, I want to make sure I have that right. All right, so your job will be to fill out figure 2, which you should be able to get from page 90. You should already have this filled out. If you don't, do that now. All right, so now this is where we explain our reasoning. All right, so these will be, you circle one or the other and fill in the blank. All right, so figure 1 is an endothermic reaction. We've said that multiple times now. So I'm just gonna cross out this so it's not confusing for me. Because the energy of the products is 4 joules, right? From right up here, the energy of the products is 4 joules. Is higher or lower? Higher than the energy of the reactants, which is 2 joules. All right, 4 is greater than 2, so 4 is higher than 2. This means that 2 joules of energy is absorbed, and bonds are broken. We need energy in order to break bonds in an endothermic reaction. Equation number 2 shows the breaking of bonds between Na and Cl. Figure 1 and equation number 2 both show an endothermic reaction that absorbs energy and breaks bonds. Okay, you see how we did that? So now figure 2 is your job. Remember, figure 2 goes with equation number 1. So, using equation number 1 and figure number 2, explain why those are exothermic. You can use this same format and copy it down here if that works for you. Okay? All right, and then when you are done with this, make sure to take a picture of both sides of page 91 and submit it to Google Classroom and check your answers on BB time.